Hey everyone, in class I described what this process was and where it came from. This little video is just to work a couple more examples so you have something kind of short to refer to if you're having trouble remembering how to do this, okay? So again, go back to the class video if you would like to get a better understanding of why it works and why we're doing what we're doing. That was all explained. This is just going to go over the technique. Okay, I'm just going to take a few of the CUDA problems and work them slowly, step by step, explaining the steps as I go along. Okay, I'm going to pick number 2. Okay, number 2 is a squared minus 2a minus 8 equals 0. Okay, and realistically, just so you know, we really have what this is this is a quadratic, right? That y equals this, this was an x, but we want zeros, we want solutions, so it's been set equal to 0. Step 1, okay? Move the negative 8 over to the other side and do not forget to change the sign. Many of you were moving it over. Especially if this was a positive, you were moving it over as a positive. But if this is positive, this side has to be negative. In other words, this is what we're doing, right? We're saying, hey, plus 8, that gets rid of this 8 and puts the 8 over on this side, okay? Step 2, identify half of the B term here, okay? So if you notice, you also often see put a little arrow down and hit the -1, okay? But the idea is to identify that is actually what's going to go in your little square here, right? And then add the square of this. If this is negative, -1 times -1 is going to be a +1. And immediately put the +1 that you added on the left side, add it over to the right side. Again, one of the most common problems is to forget to add to both sides, okay? So now what I have is, I have a perfect square trinomial. A squared minus 2a plus 1 does equal this, and this is equal to 8 plus 1, which is 9. Okay, so step 3 now would be to take the square root of both sides. When I take the square root of a minus 1 squared, I just get my a minus 1, okay? But when I take the square root of 9, I could get both a plus or a minus 3. When I take the square root, I'm always going to get that plus or minus, okay? So now again, I have to move the 1 over, okay, if I want to isolate a. What I have is a is equal to 1 plus 3 or 1 minus 3. That's 1 plus or minus 3. That's going to equal a 4 or a -2. These are my solutions for -2, okay? As explained in class, I could have factored this. This tells me if I have integer solutions that I could have factored. And if all I'd ever wanted in this whole process out of this quadratic was roots, we're going to find that the first thing you should do is factor, okay? Because I could have actually done my little cross tool. My original was this one here, right? And I would have said that's going to be a 4 times 2, and the 2 being negative, I would have had this. And remember that roots will be just the opposites of these if a is equal to 1. So that would have been the way to go. However, as we also talked about, one of the things we're going to be using completing the square for is to get the vertex form, and I almost have it here. It's actually going to, if it's equal 9, then it's going to be a -9. So that's where we're going on Wednesday. All right, I'm going to work another example. This one will not be integer roots. Okay. I'm going to pick number 12. I don't believe that is one that I worked in class. Okay, so that's my equation. And some of you immediately realized that I don't necessarily have to. I could subtract the 6 and bring it over here and then bring that over here. But again, since my strategy is to get this a blank, right? to be able to add whatever I need to add to complete the square, well, that would mean subtracting 21, right, from both sides. So that would get rid of this, okay? And so then I have negative 15. Another problem I saw a lot yesterday was just simple arithmetic errors. And you're juggling a lot of different new things, so that's understandable. Just slow down and be careful, okay? All right, take half, right? Take 1/2 of the b term, that's negative 4. That's what's going to come down here, but then add the square of negative 4. You're always going to add this because it will always be, when I square a number, whether it's positive or negative, it will always be a positive result. Add 16 to this side, add 16 to this side, okay? And now this gives me, this perfect square trinomial is this squared binomial. We found the equivalent square, and when I take negative 15 plus 16, I get positive 1, okay? Now I'm going to take the square root of both sides. Taking the square root of a square just frees it from its square. The square root of 1 is 1, but it could be plus or minus 1 again. So p is going to equal, I'm going to have to add 4 to both sides, right, to move it over. 4 plus or minus 1. I don't leave it like this. What this is this is 4 plus 1 or 4 minus 1. So it's going to equal either 5 or 3. And again, I could have actually factored to find these integer roots. I'm going to have to work another one to get one that would not have factored, okay? But again, if I want the vertex form, I'm going to be using this part of it, okay? That's one more. Okay, I'm going to work number 11, all right? Okay, again, I'm going to move that negative 48 over. I'm going to add 48 to both sides to clear that out, and that gives me something that I can complete the square with, okay? Negative 6 plus 48 would be 42, okay? So now I can see I'm not going to get an integer answer because that is not a perfect square, all right? Then I'm going to take half of 2, that's positive 1, half of positive 2, add the 1, add the 1 to both sides, okay? Actually, I'm going to get 43, square root of 43 here in a minute. You can see that. But now I've got my perfect square trinomial. This and this are the same thing, and now this is equal to 43, okay? Take the square root of both sides. When I do that, the left side just gets free of the square, but the right side, I'm going to get both a plus and a minus the square root of 43. And 43 is a prime number, not a square number. That's as far as I'm going to go with that. Again, move the 1 over, okay? And m is going to equal negative 1 plus the square root of 43, or negative 1 minus the square root of 43. I'm going to write it out like that. Sometimes if I write the plus or minus, it's not really clear. I do have 2 solutions here, and these are 2 numbers. I could do decimal estimates if I got my calculator out, which is particularly handy, but on these, you weren't asked for calculator estimates, but make sure that if you do need to calculate a calculator answer that you can do so. Okay, the way I'm going to do this, I'm just going to put my negative 1 plus the square root of 43. Put that right in my graphing calculator. That's going to be my first solution, 5.56 rounded, about. This would be the approximate solution. Okay, and then I actually, with these graphing calculators, you can hit second function entry. That'll bring up the previous answer, and I'm just going to go over and change that plus sign to a negative sign, then I don't have to re-enter everything and hit enter again. And then I'm going to get my other answer here, negative 7.56. Okay, so these would be decimal estimate answers for this. Okay, so that should give you enough examples if you're still a little bit shaky on this, but practice it enough to get accurate and be able to make sure that you can understand it, and I will see you in class.